should have done this.
What is that?
That's what?
This little ting that's going off into that.
Okay, sorry about that. Okay, so this is actually pertaining to number 1 through number 4, because they're the same. Hey, could you do double practice? Okay, so we're talking, this is type B blood. 11% of population has type B. We either had this on the test or on one of the other practice tests, so, but the questions are probably slightly different. Okay, so number 1, what are we asking for? How many blood donors should they expect until you get like your first one? Yep, and I suggest you do this even though I don't ask for the model. Again, it helps with extra credit. You know, it helps me explain, not extra credit, I'm sorry, you got me on that. Just partial credit, knowing that you know what you're doing. Okay, so this is definitely a geometric. What's our proportion? What's our p-value? 0.11. Okay, so success is going to be you are type B. That means failure is you're not type B. Is everybody good with this? Okay, so what are we asking when we say the expected value? Or how many do you expect to get until you get your first one? Okay, yeah, you want the expected value, the average of this random variable. It's 1 over rho, 1 over 0.11 or 9 point something. Okay, does that make sense? Everybody good with that? So we can expect it's going to take 9 people coming through the list on average before you get your first type B.
I was thinking that one was like a binomial model.
Binomial would be, so the key word here is to get your first type B, to get a type B. So in other words, so binomial would be like, hey, out of 10, how many can I expect to get? Like more than 1? This is how, how many are going to need to come through the list till I get my first?
We're not going to need to know all that stuff pretty much for the final, like binomial. And
yeah, that's what this is. So I'm going back to, this is what chapter do you remember? Like 14 or 15 or something? So I'm forgetting the number.
I did like the whole NCR thing. Or not the NCR, but like Q to the X times P.
So that's binomial. That's not. Okay, but this is expected value, the average of a geometric, okay, versus a probability is where you get, okay, so that's good to know that distinction. Am I asking the probability of something or an average amount or standard deviation?
So you said probability.
Yes, yep. Hey, can you guys pick up a practice final here? Okay, got it, thanks. Okay, how about number 2? So this is how you set up number 1. Can you guys plug the numbers into the calculator? If I write something wrong, can you correct me? So, because I'm kind of blowing through this pretty quick. Andrew, can you pick up my practice? Number 2, what's the probability that the 10th blood donor is the first? Okay, nope. Still geometric. Okay, because they're talking the first, type B. Well, okay, so the distinction here is now they want a probability. And they want the 10th, so x equals 10. Okay, so Stan, this is where you get the, okay, so 10th till I get my first success, that means we had 9 failures and 1 success on the 10th time. Okay, it's geometric, so we don't have that combination nonsense. Is this making sense? Double check, do I have this on the formula sheet? The whole geometric model?
Yes.
Okay, great. Okay, so 0.89 to the 9 times 0.11. I've got, thank you. Okay, whatever this number is. Okay, is this making sense to everybody? I'll forego the calculation for the moment just to get through this. And then we can come back and if you got questions. Okay. All right, so number 1 was an expected value, an average. Number 2 is actually probability. What about number 3? What are we looking for here? What's this?
The NCR ones, right?
Okay, so it is a binomial. Now, let me go back to number 2. This was geometric. Okay, we were using the probability formula for that. Okay. So this is binomial. What was the clue that it was the binomial that we switched?
It's like when they say you choose one or choose 2.
That's good.
2
For the number of successes.
Yes. So n is the total number of attempts. Y is the number of successes. That's what the binomial is. And this is your, number of trials. They've given you both. Where we're trying 20 and there's 2 successes. Okay. Do they want an expected value or a probability on the 3? Probability. Okay, so look under the binomial for the probability formula. Make sure this is x equals 2. Make sure it's not like a less than or a greater than. This is an equal, so it's the most simple form. You got the combination thing. So n and your number of successes. So this is 20 and 2. And then success is 0.11 squared. Failures, that has to be 0.89, and the rest are failures. Okay. Is this making sense? Okay, so let me give you a suggestion. Everybody write this down. I want to kind of practice on the calculator to make sure you can do this to get a number. Okay, so how I would do that combination thing, I would put it in a bracket. But remember the n has to come first. So 20, you write that first. Then you go into this math function to the probability and then find the combination NCR. Okay, and then to close the bracket, and that way I can use this and multiply it to get the rest of the equation. So bracket times, and then the rest you really don't need brackets, but they are kind of nice. So the P was 0.11. That's going to the second power. Paging over to make sure you get off the exponent times. Okay, so that means Q is 0.89. And so those are the other 18. Can I see it? And I can see I've mixed up my brackets, but that's okay. Okay, I think that will put into the 18th. I got 0.282. Everybody else? Okay. All right. Deanne, let's do it after class. Okay. So I got verification from a couple people, 0.282. So 28.2%. Okay. Is everybody good?
Could you write the CPQ equation without just the
Yep.
and
C and R, at least that's the notation. So this is n factorial over r factorial n minus r factorial. Is that the one you meant?
kind of, and the P and the Q
Oh,
when it's to the power of
so this is time. Let me write it this way. I'll write it like that. Times P to the R times Q to the n minus R. Okay.
I'll ask him myself.
What always reminds me of this is, hey, this literally is how many successes. The rest have to be failures. So, this is 2. That means that has to be 18. I'm still only looking at 20 total. So anyway, that's what reminds me of the forms. Okay. Okay. So number 4, what does that look like? Last one, and then we'll go to another sheet. Anybody? Are we looking for a probability? Are we looking for, no, mean and standard deviation? Okay, so we only have 3 distributions: normal model, binomial, or geometric. One of those 2, which ones? You guys? It's binomial. Yeah, because it's not just one. It's not like your first success. It's an expected number of successes when you're looking at 150 donors coming in. Okay, so we're expecting there's multiple type B, so that's why it's binomial. Okay, so technically you could do this as a normal as well, but all I'm asking for is mean and standard deviation. Okay, so this, technically it's a binomial, but the numbers are large enough, you can do that normal approximation. Okay, this part isn't really important. Okay, if I asked you a probability, you'd want to make the normal approximation. Okay, so we just want what's the mean, what's the standard deviation, and those are the formulas under the binomial model. So n times p, and then this is square root of n times p times q. Okay, so n is the number. How many total people? It's 150. 0.11, that's p. And then square root of 150, 0.11, 0.89. Okay. Bless you. 16.5, 3.83. Okay.
So we still with the problem number 1, the 11%, we use the...
Yes. Yeah, number 4, 1 through 4 all use the type B blood type problem.
So this is a binomial, not a normal?
It is a binomial technically, but the numbers are large enough. N times P is pretty large. It's still 16. Remember, it's above 10. If you want to, and I was asking you a probability, you could approximate this with a normal model. It ends up you don't need it because all I was asking for was mean and standard deviation. Where you would want to use this is if I asked you a question like that, you know, a probability, and especially if I gave you a greater than or less than, you'd want to, you know, you could do those multiple combination terms if you wanted to, but it's a lot. The better thing when the numbers are so large, do the normal approximation, draw your model, see where 15 is, and then, you know, we're doing that sort of thing. It ends up it's not what I asked in this case, but that's fair game, so just be ready to, let me draw a line here and say this is extra. I don't want you guys to get confused if you're looking at this after the fact. Okay. I had one of these on the test. Test 2, I think. So kind of take a look at test 2. Okay. Everybody good? Can I move on to 5? Okay. So what's going on here? What do we got going on? And so you guys were asking me questions a couple lectures ago. Hey, how do I determine whether it's a sampling problem or not? That's one of the things I want to try and help you out with when you're looking at these problems. What do we got going on here? So everybody see we have 2 normal models, one for men, one for women. Okay. Possibly you might confuse this with chapter 24, you know, the two sampling models. Okay. But we're really not talking a sample here. We're talking about, hey, what's the difference between men's height and women's height. A is the average. A dot 1 or A dot I is the average. A dot II is the standard deviation. Okay, so this is meant to be A dot I is the expected value, the average of men minus women. This is like chapter 16 stuff. Adding two random variables or subtracting. Okay. And then A sub II is the standard deviation. So, like, we would probably start with the variance and then eventually take the square root to get the standard deviation. Okay. Subtracting two random variables, and I want the average. What happened to the means when I subtracted two random variables? Nope, variance is add. Subtract the mean. I'm hoping this makes sense. You know, on average, men are 69.1 inches. On average, the women are 64. On average, what's their difference? About 5 inches. Doesn't that make sense? You're just going to subtract the averages. Okay, so 69.1 minus 64. So we're talking 5.1 inches. On average, the difference. Okay. So then, Deanna, now I want the standard deviation of that difference. Yeah, well, maybe I did. Okay. Variance. So I subtract two random variables. What's the variation? The variance is add. So variance of M. And I realize I ultimately want standard deviation, but I got to go through variance to get it. Oops, come on. Men. Women. Did we give you information to get the variance of men? Yep. So 2.8 squared. 225 squared. Okay, I don't have a number for that. Standard deviation, men minus women. It's the square root of these two.
Somebody do the math on that so we can
It's
figure
14.
Thank you.
I don't have that calculator.
And then I got
3.75.
Yep, 3.75. That's what I got. Okay. Is this making sense? Okay. Okay, what about B? B seems possibly. We just calculated the mean and standard deviation of their difference. Okay, so we could generate a normal model of that. Okay, so the idea here is difference. If I put a problem like this on the test, I'd say the difference is also a normal model. I would have added that. Okay, so what did we say? The average difference is 5.1. We said the sigma is 3.75. Okay, let's just do a couple of tick marks. 1 sigma, 2 sigma, 3 sigma. So 8.85. If I subtract, that would be 1.35, I think. And then we get negative numbers. Negative 2.4. Okay. Can anybody tell me what portion of this graph or this model is men are taller? What's the portion that men are shorter? Where is taller, where's shorter?
Well, if we're looking at men minus women, if it's a positive number, they're taller.
Yeah. Here's 0. That means they're the same height. This section's men's taller. This section, men are shorter. They want the probability that men are shorter. We're just talking this portion of my normal model. Okay, is this making sense? So we had individual statistics for men and women. We created a new random variable, their difference. This is what this is meant to represent, the difference. This is men minus women. Okay, it ends up being normal. Okay, this section is taller, this section is shorter. They want the probability that women are shorter. So I just need to calculate this percentage. Okay. Are you okay if I use normal CDF for this? Everybody good? Okay, so if I was going to type this in on the calculator, so probability men are shorter, normal CDF, lower bounds. Okay, does everybody see my mean is 5.1? That's my sigma. I just need something really, I'm adding all this up, so I'm, I don't know, minus 10, minus 20, just something very low. Okay, minus 20 maybe. I'm going up to 0 when the model has a mean of 5.1, a standard deviation of 3.75.
Is this where you have to use like
No. Nope. That would be if you were doing chapter 24 and I was doing a sampling distribution. This isn't a sample. Think of this as like picking one male and one female, not a group, a group.
So is this finding a z-score?
Yeah,
It
this
is.
is
It is. You could do z-score as well. I'm just choosing to do this if that's okay.
This is so easy.
Okay, so let's practice that. Make sure you can do this. If we have time at the end, I'll come back and do the z value method for this as well. Okay, remember this was under distribution, so you gotta do the second button for distribution. Second one down is normal CDF. Okay, so if you remember I did minus 20, I wanted something way to the left. So minus 20, comma, we went up to 0, comma, the mean was 5.1, comma, the standard deviation was 3.75, close bracket. Does everybody see, if you can see this formula sheet, I've got that on there, normal CDF. Lower bound, upper bound, mean, standard deviation. Okay. That's the order that you enter these. And so I got like 8.7%, 0.87. So 8.7%. Okay. Hold on a second. So this is equal to 8.7%. This is what we're looking for. Yeah, Nick. I'm sorry. Hold on, Nick. I apologize. Yeah, go ahead.
What's just like the key that we know that it's just a normal CDF problem that how we didn't notice?
For me, it was they're asking for a probability, so I'm like, what model can I use? We only have 3: binomial, geometric, or normal. And in A and B, or the 2 above, we calculated mean and standard deviation.
So it's
Yeah. I'd be more clear that this was a normal model on the final. Okay. All right. Yes, Nick. Sorry.
The same thing. So, and that problem we're going to ask if the men are short, or we have to put it in the question that we do, so we determine what we're going to do.
Ask it again. I'm sorry.
Because you ask me whether the men are shorter to the woman. So, for example, you can ask they shorter or the woman are shorter. That's what we have to put in the question we ask.
Yeah.
Just the way that you put it, like, because the way you subtract it.
Let me offer this as a suggestion. 3 models. All 3 models are on the sheet there. Okay. Geometric, binomial, normal. For all 3 of these, I have an expression for mean, an expression for standard deviation, and a method to get a probability. Okay. So those are the only 3 you got. And so you had 2 of them in problem 1 through 4. You have this as normal model. I'm not sure. Okay. That's the way to limit it. Yes, Deanna.
I'm sorry,
You're fine.
I'm not clear where you're getting the 0 from.
The 0 because this is where the shorter or taller comes in. You just have to recognize, hey, what was this model that we generated? What has a mean of 5.1 and a standard deviation of 3.75? This is their difference. So if the difference is a negative number, the women are taller. If the difference is a positive number, the women are shorter. shorter. Okay, so 0 here is just the transition point between taller and shorter. That's, it's more an application, I guess, and understanding that transition. Okay. All right, so let's move on. Number 6. Okay, so different problem, although it's still normal stuff. So we're talking SAT scores. Okay, so what do we know? 2003, the mean on the test was 21.4, sigma 1.05. Okay. Average composite, yep. Okay, so what is a probability? So 6, the probability a student scores at least greater than or less, or greater than or equal to 20.5. Okay. I would add on the final, assume a normal model. You kind of have to assume it since they just gave you mean and standard deviation. Okay. So here I want to talk about, is this a sample problem or not? Are we talking one student or a group of students? Ask the question, it's just one. A student. What's the probability? A student. Okay, so that means this is not a sample problem. This is just my model telling me what the students did. So this is more just a z-score, chapter 6 kind of z-score problem. So I don't need to modify this with a sample size is what I'm saying. Just use this population model that we were given. Mean of 21.4, sigma of 1.05, so let's just do a couple, just to kind of get a rough axis. 22.45, 23.5, this would be 20.35, okay. And they wanted 20.5, right? 20.5 is right here. That or more, they want this. That's giving me the probability somebody scored 20.5 or above. Okay. So how about here? Let's do the we could do normal CDF here. Let's do the Z value here, the Z score. Okay, so I'm looking for Z value. I'm going to look up this distance. So it's the value minus the mean all over the standard deviation. 20.5 minus 21.4 over 1.05. I'm expecting a negative number because I'm below the mean. Okay. I used normal CDF when I did it before. Okay. I got negative 0.826. Is that what you said?
857.
857. Okay, I entered it wrong. Sorry. 857. Okay. Negative 0.857. You'll have this available to you as well. Negative 0.8. So like 86 is what you need. Okay, so that's the 0 column. So 80, 81, 82, 83, 84, 85, 86. So everybody agree. So what was that? 19. 19.49. Okay, so this is 19.49. That's the probability I want. So um, 81 something, or 80.4 is what I got. Looks like it's more 80. Okay. Something like that. May not be perfect. That last decimal place may be off a little bit, but it's roughly 80%. Okay. Questions about this? So we're still not into sample stuff. That's coming. Okay. Okay. Now, so this was problem 6. Problem 7, we're using the same data. Okay. Use the population information from, and if there's a typo, not from number 7, from number 6. Okay. Now we're talking, hey, now we have a random sample. Now we're getting into sampling models. Okay. So when I'm drawing these bubbles, I'm still going to use the same population data they gave me above. Okay, but we're now taking a sample of 25 students. Okay, so what's the probability that the average in that sample is 22 or more? Okay, well, so taking a sample, we're calculating averages. We need to get statistics on this average, not individual students anymore. And this is where these parameters get slightly modified, more the standard deviation. Okay, so the expected value of our sample average is our mean. That's good. Okay, this is the standard deviation changes. It's sigma over square root of n. So the 1.05. Okay, but then it's going to be, we're shrinking it in by square root of 25 or 5. So 0.21 is my standard deviation. Okay. Okay, so similar model, still around 21.4, but I've really shrunk in the standard deviation. It's not 1.05 anymore, it's 0.21. Okay, and this model is not of individual students, it's of groups of students of size 25.
What did you put in the N? 'Cause it's just,
25.
okay, that's 25.
Thanks.
Sorry.
No, that's fine. That's fine. So 0.21, so 21.6, 21.8, we're just doing rough here. 21.2, 21.0. Okay, a different axis than the model we used when we were talking individual students. Okay, we want probability that the sample average will be 22 or more. Okay, so 22 is kind of out here. It's pretty far out there. Okay, so
Is that right on 3 sigma?
say it again.
Is that going to be right on 3 sigma?
But I wouldn't count on it. So,
Nice.
because I didn't put exact X values here. So let's just calculate it anyway. Let's switch, if you don't mind, let me do another normal CDF. So if we got a normal model, we can use normal CDF. You could do if you wanted to. Okay, so I want this area. What's my lower? 22. My upper, I just need to get, way the heck up there, so I don't know, 50. Mean of 21.4. My standard deviation is that shrunken standard deviation, 0.21. I got 0.21 I got 0.0021 or 0.21%. Pretty small. Okay. Questions? Okay. So we just jumped into sampling models from individual. Okay. Okay, how about, can I move on? Everybody good? Okay, so number 8. So we're talking, everybody see we're doing proportions? We're back to proportions because it's kind of like a female is either in the labor force or they're not. And that's just what this is, the problem. So success, we'll say, is female in labor force. The row they gave us was 0.46. Okay. Okay, so that actually is Europe numbers. Okay. Okay, so they're telling us they do a sample. What did they give us about the sample?
525.
Yep. What else?
229 for females.
Okay, so what am I going to do with that 229? Yeah, this is my sample success. How many were the proportion that was successful? They told me the number of success, so 229 over 529.
25.
Sorry, 225?
5.
5, sorry, 229, 525, thank you. Well, I got 0.436. 0.44 would be just fine. Okay. Okay. Not sure if we'll use that or not. The 0.46 given. Don't know. Okay. This is the sample. We want a 90% confidence interval. So what do we do?
No, I was gonna say, you don't give us actual numbers for that?
For what?
The confidence, like the 90, 99, 95.
Oh, I'm sorry. Yes, I will put that on the sheet. Thank you. Yeah, thank you. I, make sure I do that on the test. If I forget to put it on the sheet, I'll put it on the board.
If you're not giving it, we assume it's 95%.
Correct. But I did give you 90. Okay. And so that's 1.645 is 90%. But I'll put it on the sheet. Okay. Thank you. I forgot that. Okay. So how do we use, what's the confidence interval? I got a couple numbers here. You got to know which numbers to use, which not to use. So, which one? I got 2 P's. Which one are you going to use?
P hat.
Yeah, you're going to use the sample. That's kind of the key here. So we're doing a confidence interval, 90%. What is that confidence interval? P hat plus or minus your Z star times your standard error. Okay. And it's standard error, so I'm still using the P hat. Okay. So this is 0.436 plus or minus 1.645. Standard error is P times Q over N. That's on the sheet. Okay. So 0.436. Q is 0.564. N is 525. Okay. 0.436 plus or minus 0.0356. So the boundary is 0.4004 up to 0.4716. Okay. questions about that? That's a confidence interval, yeah.
How would you, review something, like we're writing?
You tell me. What does this mean? So what do we just, I always look at this. Hey, that's a percentage, it's a boundary. What's captured in that boundary? And then put it to words.
We have 90% confidence. The
Yeah.
actual proportion is between 0.4004
Yep.
and 44716.
Yeah, and we're talking about percentage of females in the workforce.
Wait, can you say that again? What did you say?
Yeah, hold on, I'm gonna write it. Workforce. Okay, so, there is a 90% confidence that the true proportion of women in the workforce, sorry, no, I'm just shortening it, is between 40%, 47.2%. Okay. Does that help? Is that? Okay. Yeah, I think.
So, if you ask, what if you asked us the actual confidence interval for 46% of the female in Europe, so we use the 46%, not the 43, 26,
This was kind of,
just a general?
yeah, you really wouldn't use this. So what you gotta remember is when you're computing a confidence interval, you're using sample data. That's not sample data. That's like prior knowledge of what's been going on. So we were doing things like estimating the sample size. Okay, you kind of work this backwards. I'm not going to give you that kind of problem. Okay, so if you hadn't taken the sample yet, okay, and you were going to use this, come on, this piece to estimate how big does n need to be, because I want a certain margin of error, I would have used that as an estimate. Okay, but that's before you even take a sample. So,
Mark,
yes.
in that question number 8, what I consider the best, greater, different, and the question, let me get a read.
Okay, so the difference is, did we ask for a confidence interval, or were we asking a question? The question is a hypothesis test. That's when you've got the less than, greater than, not equal. Confidence interval, that's the other stuff. Doesn't include that yet. That's what 9 is going to be. It's going to be a hypothesis test.
So on the test, you want us to just do the percentages or write it down?
Give me percentages given this question. Write it out if I ask you specifically interpret the confidence interval.
Okay.
Yeah. So technically, yes, this wording is extra. This is what I was looking for.
Okay.
This is extra. If I say, hey, interpret what that confidence interval means, this is what I would expect. Thank you for clarifying that.
Now, I just looked and I knew that it was a confidence interval because it said confidence interval. Are you going to do that on the test also?
Absolutely.
Okay.
Yep.
Okay.
Yep. Okay, so number 9, you kind of already gave it away. I kind of said it was a hypothesis test. What's a clue that you guys, what's a clue to you that it's a hypothesis test versus a confidence interval?
It's asking for small.
Yeah, should the representatives, so we did a sample, should the representatives here in the U.S. for the Department of Labor conclude that the percentage of females is lower than the European rate of 46%?
They do a claim.
They make a claim, yes. So, and it's a question. Is our female participation rate lower than Europe's? That's a question, yes or no. Okay. So what would our no be? Yeah, no change. So no, it's not different than Europe's, it's the same. Effie, here's a case where I will use the 4-6. Okay. So what's my alternate? I hear both. Which one?
It's
Why?
less Because it says lower.
Because that's the question. So you gotta read the question. We wanna know if it's less, so it's less. And then, we're going to, do the low end tail, right? For the model, okay. So the only thing I need to do is, how do I get the model from this? What do you do? And the problem with this is there's a couple numbers floating around. I'm trying to make you realize which numbers you use.
Did you use the sampling?
Say it again? Yes, okay. So clue here, null hypothesis stuff. I'm sorry, hypothesis testing, look at the null. This is telling me how to create my model. We made a claim the proportion is 0.46. So that's the information we're gonna use, not the sample. Okay. At least not to make a model. Okay, so this is rho 0.46. Standard deviation. We're back to I can get a standard deviation because we've assumed a proportion is the case, a population parameter. So square root of rho q over n, or pq over n, so 0.46, 0.54, n is 525.
Which formula is this under? I'm like looking.
Oh,
I see it. Is it the sampling distribution model
Yep.
for proportion? Gotcha.
Yep.
Okay.
Okay.
That's the biggest thing, man. Once you know how to do the formula, it's like plugging chugs.
Okay, consumer. Thank you. 0.022. Okay, so I need to go a little faster, guys. Sorry. So I just want to make sure I get through all the problems. Okay, so mean of 0.46. We'll do a couple of these. I'm rounding. 0.8, 0.5, 0.52, 0.44, 0.42. Okay. So here's where we look at the alternate. The alternate is less than 0.46. Actually, I'm sorry, no. Less than is what we're looking for. Where do I go here? Yeah, where's my boundary? Nope. 0.46 is the middle. Does that mean we have 50%? What do we remember the procedure? What do you use the null to get your model, then what do you place?
Look at less than 0.46.
Nope, well that's 50% sample. Yep. The sample was 0.436. That's what I place. 0.436 down here. Okay. So if I get that percentage, the direction was looking at the alternate. Okay, so this probability, what's the probability that a sample is less than 0.436? Normal CDF. Lower, I'm just going to do 0, 6, sorry. 0.46, 0.022. Okay. And when someone gets you guys have my calculators. So.
Somebody put that on, please.
I got it here actually.
Okay.
Okay, make sure I do the right. So 0, 0.436, 0.46, 0.022. I got 13.8
Yeah.
Is that, okay, thanks. 13.8%, thank you. Okay, is this making sense to everybody? Okay. So guess what's next? What's the next problem? We're talking illiteracy rates between men and women. Yeah, but one proportion or two? I got two because I got the two groups. Okay, so
Okay, if it's greater than 5%, you accept or reject.
thank you. Yeah, I didn't finish that, did
Yeah, I was like, you never actually answered.
Sorry. I just need to go fast. I'm sorry. So, are we keeping or rejecting the null? Keeping. So this is greater than 5%. So keep null. Okay. So that means we can't. All this is saying is the U.S. can't claim that their numbers are lower. It's not low enough to break that 5% threshold. So.
It was a 90% confidence interval, so
No.
just not.
Nope. If, so this is not tied to confidence interval, it's a separate problem. Okay. So right now, I'm assuming alpha is 5%. Okay. So that brings up an interesting thing. If I don't say it, if you wish to deviate and say, nope, I'm going to pick alpha 10, I'll grade it. And you pick your alpha, but the default is 5. So if you don't say anything, don't make an assumption, I'm going to assume you're thinking 5%. Okay, thank you. That's good. Okay, so this is number 10 and 11. Okay, so we got 2. So what's your higher? So here's, I don't know. Okay. Okay, men, women, number 234, so this is men. Women, 251. They said the success for men was 45. So that means the proportion is 0.192. The success for women, 42. So the proportion for women, dividing those is 0.167. Okay. So success here is who's illiterate. That's just the way it ends up. Okay. Okay, so that's kind of the data as given. What do they want? What's the question? Test an appropriate hypothesis. Okay, the question above in the paragraph, do these results, meaning the samples that we got, does this indicate that, do these indicate the United Nations findings are correct? Okay, they're claiming a higher illiteracy rate in men. Okay. So do we think that's true? Okay, so that's a question, it's not a confidence interval, it's a hypothesis test. So when we have two proportions, do you remember how do you set this test up? You said minus them, correct? Okay. Equal to 0, that's, null is that they're the same. Okay. What's our alternate? Say it again. Higher, yeah, because they're wondering if women or men are higher, so that'd be greater than 0. Okay. So what do we got? Okay, so we have, same as the single proportion, I'm using the null to help create my model. Mean the expected value of men minus women. This is 0, because that was our null hypothesis. We need to calculate a standard error. Okay, Does everybody see on the second page the two proportion? This was the variances add thing. You got two terms. Oops. Hold on, I'm skipping something. We should. Yep, we should pool. We need to pool the data. Does everybody remember this with two proportion?
We only
Okay.
divide by added the success. We divide
Yeah.
by 4.
Yep. So what was the deal here? I've got the pooled formula there on the formula sheet. When we're assuming the two proportions are the same in the null, that's when we pool the data. So it's success men plus success women all over the two totals. Okay, so 45 plus 42 over 234 plus 251. Okay, so this is 179. Okay, kind of expecting it to be in between because we're pooling it. Okay, so when we calculate the standard error, we're going to use the pool. Okay. All right. So as this look, 0.179. The Q is 0.811. Number of men, 234. Okay, if you enter that in, I got 0.035. So anyway, anytime you do these differences, we're claiming the difference is 0. I always like these because that means I can draw my model literally around 0. It's easier to label this. Okay. So my question is, okay, great, we got our model with our null. What's the value we put on top of this?
We subtract it. It's in proportion.
Which two?
The main ones.
Yeah, the two samples. Yep. So the sample. Oops. The other way. 9 minus 1. Nine 192,167. Okay, that difference is 0.025. Okay, and so we're kind of right there. Am I going to go left or right of that?
Right.
Yeah, because the difference greater than upper end. So that, okay, is it an obvious accept or reject? Okay, everybody see we're clearly above 5% because we're within a 1 sigma. I'm okay if you don't calculate the p-value. Okay, so clearly p-value is above 5%. Okay, all right. I mean, we're right smack dab near the middle of our model. Okay, so what do you do? Accept or reject? And say fail to reject or reject?
Reject.
Fail to reject. Okay. Questions about that? Okay, got two more problems. Okay, number 11, we're using this same data. What do we want here? %95 confidence. Okay. So what data do we use? This is another one. You got a couple of values kind of floating around. We want a confidence interval. What's the true difference? That's what they're asking. Remember, for a confidence interval,
What are you asking?
when you're doing a confidence interval, which data are you using? Sample data, population data? Sample, yeah, so I'm gonna go back to this table. Okay, so confidence interval. Okay, plus or minus some z-value times standard error of the difference. Okay. We already know that difference. We calculated it. It's the 0.025. What's our z-value? 1.96. Yep, that'll be on the test. Okay. I gotta calculate a new standard of error. Okay. Because when we're doing confidence interval, we're not making a claim that the two proportions are the same. We're not going to pool the data. Okay, so 0.025 plus or minus 1.96. Let me write this one out. Okay, I've got the two terms. And 0.191, 0.819 over 234, that's the male data. Okay. Female data, 0.167, 0.833, 251. Okay. If we type that in, okay, so 0.025 plus or minus 1.96, just that square root, 0.035. Little less than the pool. Actually, it's right at what the pool is. If you calculate this out, the boundary is negative 0.44 up to positive 0.0936. Okay. So what if I ask you interpret the confidence interval? Put everything in there. What would you say this is?
We are 95% confident that the true rate of literacy in men and guitar, it's long, is in between 0.044
and it's a difference.
Yeah.
It's the difference between men and women illiteracy. You either have where the women is higher, the negative difference, or a positive difference, So we're not sure what the difference is. It's somewhere in between this. Okay.
You can go down a little bit.
Yes, absolutely. Okay. Okay, so while Nick's doing that, everybody else start reading that last problem. Okay, so let me make a comment about this. I've got raw data there. These are numbers, right? So this is like, this is going to be a sampling model for mean. Okay, I'm going to give you the statistics on the final. How many, the mean, the standard deviation, and the degree of freedom. That'll all be on the test for you. Okay, so if I did that, so this is number 12.
Do we need to write out like what you just said about the difference? Like
only if I ask you
Okay.
interpret the confidence interval.
okay.
It's another extra because I don't believe I did. Oh, I did say interpret the interval. Yeah, yeah. So I would expect the words.
Okay.
Okay. So what's this quantitative data? This is about like word length in a book. You know, someone's just counting words. How many letters in a word? Okay, and they just pick 20 words, not many, but they just pick 20 random words out of a book. Those are the lengths. Okay, so lengths. They picked 20 words. The mean, if you added all those up and divided by 20, you got 5.5. Okay, so on average, a word is 5.5 letters long. That's what it's saying. And then the standard deviation is 2.69. Okay. I would write this, the degree of freedom equals 19. In this case, it is n minus 1. But I'm going to tell you, I'm not going to make you guess what the degree of freedom is. Okay. Okay, so what are they doing in 12? What are they doing? I'm going to reword 13 a little bit. Okay, let's do 12 first. What do they want to know in 12? The editor wants the word length to be 6.5. Okay, he wants he wants 6.5 at least. Okay, he would like to have a mean word length of 6.5. Our sample came up a bit short. The question is, does this sample suggest that we failed the goal? You know, we didn't meet the goal. Okay, is that a question or is that a confidence interval that we're calculating? Question, okay. So we got a null, we got an alternate. Okay, quantitative, so we're not doing proportions anymore, we're talking means. Okay, so what's my null?
Equals to 6.5.
Yeah, that we met the goal. Okay. And then the question is, he thinks possibly we didn't meet the goal. So is everybody good less than 6.5?
Where does it say it?
Um,
6.5.
In part 12?
It says he hoping it would have a mean
Yes.
of 6.5,
Right.
at least 6.5.
You're right, of 6.5, you're right.
So then would it be not equal?
Fail the goal. Yep, you're right. Not equal. I agree. I would,
Good catch.
little squirrely in the wording, I'd take either one in that case. I'll give a much clearer, less than or greater than. If I don't, I'll take whatever you put in there. Okay. Okay, so what do we do? How do we? Magic, right? Yeah. Use the null. We get a model of what these means should look like. The average of our means are the population, and we're assuming it's 6.5. Okay. Those means are all not the same, or the sample means, so they have a standard error. Which is S over radical N. Okay, if we had a population, we'd use standard deviation, and it would be sigma over N. Okay, and so this is the 2.69 square root of 20, and we got 0.602. Okay, so we got a model here. Mean of 6.5 sigma, so I'll just do a couple of these. 7.1, because we're adding 0.6, 5.9. 5.3. So again, this is just 1 sigma, 2 sigma, 3 sigma. Okay. Now what do I do? What value do I plop on there?
5.5.
Yeah, the sample that we got. So 5.5. Okay, and we said not equal, right? Okay, so we probably should calculate the z-value, and then we're going to reflect it. At least this is the picture, but we'll do the 2 times. You know, you don't have to literally do this. We're gonna calculate that probability and then just double it because of the symmetry of a normal model. Okay. So
What is that number that you just put at the end?
5.5?
And the other one, though, on the other end.
I don't know. I'm
Okay.
just graphically, it's gonna be symmetric.
Okay.
Same distance, but on the upper end.
Okay.
We're doing the 2-tail because you guys correctly corrected me that it was a not equal. Okay, so how do we get this? What do you want to do, z-value or normal CDF? CDF, okay. So, our p-value is 2 times the probability that the sample is less than 5.5, because that's just this end, and then we're doubling it. Okay, so 2 times normal CDF. Okay, lower bound, I'm gonna go down to 0. I mean, just something way back over 0 up to 5.5, mean of 6.5, standard deviation of 0.602. Okay. So you could do 2 times on the calculator, 2 times, then go grab the normal CDF function. Lower bound, I said 0 up to 5.5, comma, mean of 6.5, standard deviation of, what was it again? 0.602, 0.602, and doubling it, you got 9.7%. Okay. So even doubling it, you got 9.7%. Okay, so what does that mean? What are you going to do? Fail to reject. Yep. So we can't say that we failed the word count. We may be just fine in meeting the 6.5 goal. Okay. Okay, last one. So I'm going to reword a problem like 13. I'm not going to ask you a sample size. Like what's the sample size? I'll just ask you a confidence interval. So it'll be, these samplings will be very straightforward. It's either a hypothesis test or if it's a confidence interval. I'm not going to do any of those kind of minor deviations. Okay, so they said 98%. Okay, I forgot what the number is for 98%, but 98% confidence interval.
So 2.33.
Thank you. Appreciate that. But it will be on the, actually it's on your Z, that T table as well. Okay. Okay, so what do we do here? What do we do here? Actually, this is wrong. Sorry. We're going to need to use the T-table. Okay. So how do what's the formula for confidence interval? We're going to take your sample plus or minus your T-value. Okay. Degree of freedom, I told you it was 19. Times the standard error of the mean. Okay, luckily we've calculated all of these. So the mean was 5.5 plus or minus. We got to look up the T-table, and I didn't bring that with me. I got it right here electronically. Okay, so if you look at this, we're down here 98%. Degree of freedom, it's this column. 2.539? That's what I got. Okay, 2.539. times, we already calculated standard error, and that was 0.602. Okay, so 5.5 plus or minus 2.539, 0.602. I got 1.528. So low bound 3.97 all the way up to 7.028. Okay. So what did we just calculate? And I'm running late. Sorry, guys.
Interval.
Say it again.
Interval.
Interval of what?
98%.
Of what?
Of the words.
Average word length. Yeah, we're not quite sure what the average word length is. We're 98% confidence it's between these numbers. Okay. Is that making sense? Okay, that's what I will cover. So I'm not putting a chapter 24 problem on the final. It only goes up to chapter 23. Yeah.
I said 2 to 1.
Yeah, if you're doing a percent before, if you're doing a decimal for a percentage, great. Okay, I'll see you on Tuesday.
Check your payment email. I'll send it there. Or your class email.
Anytime you're doing
What did he say?
sampling for me.
No, I swear. What did he say? I haven't.